So how is the reaction? So we'll see. Okay, I'll write it here. So I'll write it here. So what we have taken, they have taken toluene. Toluene is also called as what? Methyl benzene. So this methyl benzene is treated with CrO2Cl2. Okay. So in the presence of CS2, that is carbon disulfide. So what you get X? So your X will be CH. Okay, and your two CH groups will be replaced by what? This particular group, that is O CrO HCl2 twice. Okay, this will further undergo what? It will undergo further hydrolysis to give you your benzaldehyde. So yes, so what is our correct answer? It is B. Okay, so the answer is B. Are you able to see the screen? Yes, okay. So we'll go for the next question. So the first question, it was asked in NEET 2021 paper. Okay, so this question was asked in NEET 2021 paper. So next question, identify the compound X in the following sequence of reaction. So they have given a sequence of reaction. Okay, so you need to write the what X. So again, here also you have to tell the intermediate what it is found. So this is first one. Now we'll write the second one. So the reaction again, they have taken a toluene. Okay, they have taken toluene. Then you are reacting it with chlorine in the presence of HV, that is light. Okay, H nu. So chlorine in the presence of H nu means it is undergoing free radical mechanism. So it will give you a product X. So what will be the product X? So X, and further it undergoes hydrolysis. So you have to tell which is the product. So this will further undergo hydrolysis at 373 Kelvin, and you get again benzaldehyde. So again, this is also one of the reaction which we have seen. Yes, what is the product X here? Yes, what is the product X here? The product is CH. Yes, what is the product? So one of the hydrogen will be replaced by your both the Cl2. So it is CHCl2. Okay, CHCl2. Option number C. Okay, option number C. Okay, option number C is the right answer. I hope this is clear. So, so this reaction also we have seen wherein toluene. Okay, toluene we have done the free radical mechanism, that is chlorine Cl2 molecule in the presence of light. Okay, it gives you benzyl chloride. So this the name is benzyl chloride. It is benzyl chloride. Okay, so it is called as benzyl chloride. So this benzyl chloride further it undergoes hydrolysis. Okay, to give you what? To give you benzaldehyde. So this is the second reaction. Okay, this is the second reaction. Now we'll see the third one. So this was the question. The second question was asked in NEET 2020. Okay, this was a question asked in NEET 2020. Next, reaction by which benzaldehyde cannot be prepared. Okay, reaction by which benzaldehyde cannot be prepared. So which is the reaction in which benzaldehyde can be prepared? See the reactions, four options. So this question was asked in NEET 2013. Okay, so which is the so first is benzene reacting with carbon monoxide plus hydrochloric acid in the presence of anhydrous AlCl3. Okay, then your carboxylic acid That is benzoic acid plus zinc in the presence of Hg and concentrated HCl. Then third one is toluene plus CrO2 Cl2 in CS2 followed by hydrolysis. And then is your acid chloride, that is benzoyl chloride is taken here, plus H2 in the presence of palladium and barium sulfate. So by this reaction, you can produce your benzaldehyde. They have asked which is the reaction from which benzaldehyde cannot be prepared. So from this reaction, just now we saw benzaldehyde can be prepared. Then with acyl chloride also you can prepare your benzaldehyde. So this is also wrong. Okay. Then here with your benzene and carbon monoxide HCl, and this also you can prepare your benzaldehyde. So this also is wrong. So you know that when you are taken a acid, okay, now they have taken what? Benzoic acid. So this benzoic acid, when you treat it with zinc Hg, that is called as zinc amalgam in the presence of concentrated HCl. What is done? Your carboxylic group is reduced into what? Or your CO group is reduced to alkane group. Okay, so this is what? So this is Clemmensen reduction. So Clemmensen reduction in the presence of zinc and amalgam, that is zinc amalgam and concentrated HCl. What it does, it reduces your aldehydes and ketones to CHO. Your aldehydes and ketones is reduced to CH2. Okay. But here the carboxylic acid is there. So carboxylic acid will remain intact. Okay. It will remain intact. So it will be unaffected. So it is option number B. Okay. Option number B is the right answer. So option number B is the right answer. So a reaction by which benzaldehyde cannot be prepared is your option number B. So your respective aldehyde or ketone can be converted into alkanes. Here, what is there? Carboxylic acid is there. So it will remain as it is. Okay, there won't be any change in that. So next question. Okay, here it is. So fourth question. Consider the following reaction. So this is a reaction. Okay, this is the benzoyl chloride. So benzoyl chloride in the presence of H2 and palladium and barium sulfate. So what will be the product A? What you will get? What is the product you will get? I'll write the reaction here. Try to solve and see. COCl in the presence of H2, palladium and barium sulfate. What you get? You get your, okay, C. Mm, so COCl, COCl. So COCl in the presence of H2 and palladium, this, okay, it is, this name reaction is called as Rosenmund reduction. Okay, this is a Rosenmund's reaction. So this name reaction is called as Rosenmund's reduction, wherein your what is happening? Addition of hydrogen is taking place. Okay, and there will be removal of oxygen. So this will give rise to a aldehyde, benzaldehyde. Okay, so this is Rosenmund reduction. So option number A. Option number A is the right answer. So the product which is formed in by following reaction is benzaldehyde. So this is the Rosenmund reduction. The name reaction is Rosenmund's name reaction. Okay. Then the next question, fifth one. Which one of the following can be oxidized to corresponding carbonyl compound? So which one of the following can be oxidized to corresponding carbonyl compound? To hydroxypropane, B orthonitrophenol, C phenol, and D 2-methyl 2-hydroxypropane. 1, 2, 3. So 2-hydroxypropane, right? So which one of the can be oxidized to corresponding carbonyl compound? So this is a secondary alcohol. So secondary alcohol, when it undergoes oxidation, okay, it will form what? It will form ketone, right? It will form ketone. So answer is A. That is 2-hydroxypropane. Orthonitrophenol, no. Phenol, no. 2-methyl 2-hydroxypropane, no. So this, okay, when you do oxidation, you will obtain a ketone. So it is converted, it can be converted to either any of the carbonyl compounds. So here it is converted into, okay, so here it is converted into what? Here it is converted into ketone. Okay. So correspondingly, whenever you have primary alcohols on oxidation will give you what? Aldehyde. Okay, and when you have secondary alcohols, so secondary alcohols, when they undergo oxidation, it will form ketones. Okay, and tertiary do not react. So this is the reaction. Next question is sixth question. In the following reaction, the product P is, so they have taken acyl chloride. Okay, so there is a acyl chloride. So acyl chloride in the presence of hydrogen. So this is Rosenmund's reduction. Okay, so what you will get? What is the answer? Just see. What will be the answer? Sixth one. What will be the answer? Rosenmund reduction is what? You are removing the oxygen and you are adding hydrogen. Okay. Okay, so it is what? Option number C. Yes, it is option number C. So it is converted into aldehyde. Okay, so removal of oxygen, addition of hydrogen. So this gives you what? So this gives rise to a aldehyde. So this is a Rosenmund reduction. Next is seventh one. Which alkene on ozonolysis gives CH3, CH2, okay, CHO and CH3, CO, CH3. So you have to see which alkene. So here what we are going to do? We are going to add the this what? How to do this ozonolysis reaction? So if you take the first one, we'll see CH3, CH2, CH double bond C, CH3 and CH3. So on ozonolysis, it should give what? So ozonolysis means CH3, CH2, CH. Okay. So what we will get now? So I have added the ozone molecule. I have added the ozone molecule. Right. So what will be the product now? So I'll get CH3, CH2, CHO, and here this will be CH3, CO, and CH3, like this, right? So option A is the right answer. So ozone molecule should be added across the double bond. So we are adding a molecule of ozone, and then it will. So this is ozonoid form. So when it forms like this, so we are adding the ozone across the double bond. So this is a ozonide formation. This is a ozonide formation. Okay, so these are the products which are obtained. So option number A is the right answer. Okay. Next question. In the reaction, that is methyl cyanide plus 2H in the presence of HCl and ether gives you X. This, so I'll write it here. So CH3CN plus 2H in the presence of HCl and ether. Okay, it gives you X. This X further with boiling water, okay, gives you Y. So you have to tell what is Y. What is Y? So when you are converting your nitriles, what is done? Nitriles is taken. Okay, CH3C triple bond N plus 2 gives you what? Your X will be what? So CH3 CH double bond NH. What is formed? Imine is formed. So your nitriles are converted into imines. Okay, this imines is further treated with water. Okay, you are heating it with boiled water. This is converted into CH3 CHO plus NH3. Okay, so what is the answer? It is acetaldehyde. So option number A. Option number A. So what we are doing? So this nitrile, when it is added, so we are adding the hydrogen. So that is, it is a reduction reaction in the presence of hydrochloric acid and ether. You get CH3, CH, double bond, NH. So it is a imine. Okay, imines. Then when you heat it, so further you have to heat it. So you get Y. What is Y? It is acetaldehyde. So acetaldehyde plus ammonia. So option number A is the right answer. I hope this much is clear. We'll go for the next one. Okay, so next we'll go for chemical reactions. That is 12.4. Just see 12.4. Okay. Now here, first one. What is the IUPAC name of the organic compound which is found in the following chemical reaction? So a chemical reaction is occurring wherein you have taken acetone. Okay, acetone in the presence of ethyl magnesium bromide. Okay, dry ether. It is undergoing hydrolysis. Okay, it is undergoing what? It is undergoing hydrolysis. So what is the product P? They have asked what? What is the product P? Yes. What is the product here? When acetone, what you have done? You have taken acetone. You have treated it. This is a Grignard reagent. Okay, this is a Grignard reagent. So Grignard reagent, when you are treating it with Grignard reagent in the presence of dry ether, then it undergoes hydrolysis. What is the product P? So how the reaction takes place? Just see CH3, C. Okay, so OMGBr and this will be C2H5 group will get attached. Okay, so at O negative part, your MgBr group will attach and to the carbon, your ethyl group will be attached. So this will be CH3. So this when it undergoes hydrolysis, that is hydrolysis, it gives you what? CH3, then is CH2, C, CH3, OH and CH3. So write the name. So the name is 2-methyl. So at 2 position you have methyl group, 2-methyl butane 2 all. Okay. So the correct answer is what? The correct answer is A. Which is the correct answer? Correct answer is A. So acetone, it is reacting with Grignard reagent. So at your oxygen, your MgBr group will be added and to your carbon, what will be added? Ethyl group will be added. So when it undergoes hydrolysis, what it will form? So CH3, CH2, then C, CH3, CH3, OH. Okay, so it is 2-methyl butane 2 all. I hope this is clear. So we'll go for the next one. So this was a question asked in NEET 2021. Next question, reaction between benzaldehyde and acetophenone in the presence of dilute NaOH is known as A. Aldol condensation, B. Cannizzaro reaction, C. Cross Cannizzaro reaction or D. Cross aldol condensation. Yes. So for aldol condensation, you know at least one of the aldehyde or ketone should have a alpha this. Yes. So at least one should have a alpha. alpha hydrogen, right? So whenever you have aldehyde or ketone, whenever aldol condensation should take place. Now, what is the structure of benzaldehyde? So benzaldehyde, it is this. So this is a benzaldehyde and acetophenone. So this is acetophenone, right? So yes, so benzaldehyde plus acetophenone. So this is in the presence of NaOH, what it gives you? CH double bond, CH, C double bond O, CH3. Okay. So it is benzyl acetophenone. It is benzyl acetophenone. So this is a cross. So this is what this is a cross aldol condensation. Okay, it is a cross aldol condensation reaction. So it is a cross aldol condensation reaction. Next question, consider the reactions. Okay, you have taken the reactions. No, we'll go for the next one. Just a second. Yes, go to the 14th question. Okay, 14th question you check. So of the following, which one is the product formed when cyclohexanone undergoes aldol condensation following by heating? So what is cyclohexanone? What is the structure of cyclohexanone? So whenever, what they have said, that is whenever cyclohexanone is there. Okay, so when it is heated, so it should undergo aldol condensation. So what will be the product which is formed after undergoing aldol condensation? Yes. Okay. So from here, one of the hydrogens, so this will be negative part. So this will attack here, this will go here. So what you will get now? Okay. So I'll just flip this. Okay. Till I flip, you won't understand. So this is attacking here. So like this, double bond. And here you will get your double bond OH. So this will attack here. Okay, and this will attack here, right? So this will attack here and this will attack here. So option number A is the right answer. So this is undergoing a aldol condensation reaction. Okay, aldol condensation reaction. Next question. The correct structure of the product A formed in the following reaction is. So there is a reaction given, that is a product. So here this is a product. So this in the presence of H2 gas. Okay, at 1 atmospheric pressure. Palladium in the presence of carbon and ethanol as a solvent, you get a product A. So what is a product A? So either the hydrogen should be added to C double bond C or your C double bond O carbon. So it is a reduction reaction wherein your hydrogen molecules will be added to the C double bond C bond. Okay. So C double bond C bond, because C double bond C bond is reduced faster than C double bond O bond with hydrogenation. So when you are doing hydrogenation and you have two systems, that is C double bond O and C double bond C. So this will be more faster. So the addition will take place more vigorously at C double bond C. So the answer is, so when you add a hydrogen, so this will be option number B. Okay, the answer is cyclohexanol. Here, now in this case, what you have, this is a reaction. Okay, so what we are doing a hydrogenation reaction. What do you mean by hydrogenation reaction? We are adding hydrogen. Okay, so hydrogen is added across. So there are two, what you can say, there are two ways. Either the hydrogen can react on this particular carbon, that is C double bond O bond, or it can add to C double bond C bond. Okay, so either the addition of hydrogen can take place at C double bond O or C double bond C. Here, the addition of hydrogen is faster. Okay, when you have, so they have two options. That is C double bond O also hydrogen can be added, or it can be added at C double bond C. So the addition of hydrogen molecule is faster at C double bond C. Okay, it is faster at C double bond C as compared to that of C double bond O. So C double bond C bond will be reduced faster. Okay. Then the C double bond O bond with respect to hydrogen in the presence of palladium and carbon. So when you have this condition, so C double bond C bond will be reduced faster as compared to C double bond O bond. So this is the statement what you have to tell. Okay, so the answer is what? So when you add across the C double bond this, okay, so when you're adding hydrogen. So what you are doing here, you are adding the hydrogen across this two bonds. So this will, the bond will be removed and it will give you cyclohexanone. Okay, you will get a cyclohexanone. So next question. Okay, so next is uses of aldehydes and ketones. Okay, there is some more question. Okay, uses of aldehydes and ketones. 63rd question. Formalin is an aqueous solution of. So formalin is an aqueous solution which is made up of what? So formalin, it is a aqueous solution, okay, which is made up of what? So first one, furosine, B, formic acid, C, formaldehyde, and D, furforaldehyde. So formalin, it is made up of what? It is made up of 40%. We have seen this. So it is made up of 40%. Yes, it is made up of 40% formaldehyde. Okay. So formalin, it is made up of 40% formaldehyde. So option number C is the right answer. Yes, go to 24th question. Okay, 24th question here. 24th question. So 24th question, can you see? So acetaldehyde and uh, the 6H5CH2CHO, right? So this can be distinguished chemically by. So how you can distinguish by Benedict's test, iodoform test, C tolerance reagent test, or D Fehling solution test? Yes, how you can so it can be. So one is what? One is a aldehyde. Then second one is what? So whenever you have aldehyde group, okay. So aldehyde group, whenever you have a aldehyde group, so they can be easily it can have a halofrom reaction. Okay, that is it can undergo a iodoform test. But whenever you have that is acetaldehyde, okay, it will easily show you the iodoform test. But when you have that is C6H5CH2CHO molecule, okay, so such compound it will not give you the reaction with iodine. Okay, it does not give the reaction with iodine. So the test which will be distinguished can be used to distinguish the two compounds will be iodoform test. So with iodoform test, your acetaldehyde will give you a yellow precipitate. Okay, and with the other compound, it won't give you a yellow precipitate. Okay. Next question, consider the reaction that is acetaldehyde plus this is phenylhydrazine. Okay. So when you react it with the phenylhydrazine, giving you CH double bond N NH2. So what sort of reaction is this? So what type of reaction it is? Electrophilic addition elimination reaction, free radical addition elimination reaction, electrophilic substitution elimination reaction, or nucleophilic addition elimination reaction. So this is a, so what you are adding here, you are adding NH2. Okay, it is a nucleophile. Okay, so nucleophile is added to the aldehyde group. So it is a nucleophilic addition and elimination reaction. Okay, so option number D is the right answer. Next one, which one of the following compounds will give you a yellow precipitate with iodine and alkali? Yes, just now we saw that. So, so whenever you have a ketone group or a aldehyde group, okay, so they will give you, so here which of the following compounds will give you yellow precipitate with iodine and alkali? The question is, so it is, so this example, okay, so that is yellow precipitate with iodine and alkali means it is a iodoform test. Okay, iodoform test only gives you yellow precipitate and yellow with that is with iodine and alkali. So the compound with CH3C double bond O group or CH3CHOH group. So whenever such compounds are present, okay, they only will give you yellow precipitate. So they give you yellow precipitate, okay, of iodoform. So that is CH3I3. So iodoform. So whenever iodoform test is positive, so it gives you a yellow precipitate. So your acetophenone, your acetophenone is having what? It is having a double bond group, so it will give you a positive. Uh, okay, and one more option. So D 2-hydroxypropane. 2-hydroxypropane is what? CH3 CH CH3 OH, right? So this also can give you, so you can see this. So either of this. So whenever you have a secondary alcohol like compound or a ketone like compound, so they will give you yellow precipitate. So here two answers are right. So option A also, option D also. Okay. Next question. Clemmensen reduction of a ketone is carried out in the presence of which of the following? So the question asked is, which is the reagent used for Clemmensen reduction of ketone? A. Glycol with KOH. B. Zinc amalgam with HCl. C. Lithium aluminum hydride. Or D. Hydrogen and platinum as catalyst. So what is done in Clemmensen reduction? Your carbonyl group, carbonyl group is reduced to your CH2, right? So when it is treated, what is the reagent? It is treated with zinc amalgam. Okay, zinc amalgam in the presence of concentrated HCl. So this is called as Clemmensen reduction. So it is option number B. Okay, option number B. So option number B is the right answer. Next one, 29th you check. Which of the following reactions will not result in the formation of carbon-carbon bonds? A. Rimmer-Trimmer reaction, B. Carinzaro reaction, C. Woods reaction, and D. Friedel-Crafts acylation. So which of the reaction will not result into formation of C double bond C? Okay, or CC bond. So which reaction will not give you CC bond? The answer is Rimmer-Timmer reaction. Okay. In Rimmer-Timmer reaction, it does not give you a CC bond. Rimmer-Timmer reaction. So option number A. Okay. Rimmer-Timmer reaction. When you see Rimmer-Timmer reaction, what is a Rimmer-Timmer reaction? This we have seen. It is a name reaction used for preparation of your salicylaldehyde from phenol. So phenols, when you treat it with chloroform, okay, what you in the presence of a base like NaOH, what you get? You get salicylaldehyde. What you get is salicylaldehyde, OH and CHO. Okay, you get a salicylaldehyde. So here you can see there is no CC bond. Okay, there is no, the reactions will not result in the formation of CC bond here. Okay, only the addition of aldehydic group is taking place at the ortho position. So these were some of the questions based on aldehyde and ketones. Okay. So the remaining questions based on your carboxylic acid. So we shall discuss that in the next class. Any doubts still here regarding this particular session? Okay then. So the remaining we have left with carboxylic acid, MCQs on carboxylic acid. So that I'll be dealing in tomorrow's class. Okay. So if any doubts are there, you can ask me or I'll end the session here.